All right, well, let's start then. Good morning, everyone. Uh, it's a pleasure to be here, kicking off day 2 of NDC. And I'm sure this is going to be an exciting day full of talks from lots of amazing speakers. I'm Ashish, and I'm here to talk to you all about fine-grained authorization for modern applications. It is a very critical topic, but might I say that it is a little bit underappreciated, it's fairly new, not many people know about it. But you might be thinking that, why are we talking about authorization at 9 in the morning? That's how we are starting our day. But trust me on that, when you decided to walk into this building today, you were already logged into authorization. When you checked which floors you had access to, which rooms you have access to, basically you were checking out where were you authorized to go in this whole building. So yeah, you were doing authorization the moment you walked in. So with that in mind, let's start. Okay, just a wee bit about myself before I start with the talk. So I'm currently working as a solutions engineer at Okta India. And I've been here for a couple of years, but before joining Okta, I was a freelancer for almost 7 years. And during that time, I used to primarily work in conversational AI, building apps for smart speakers like Amazon Alexa, Google Assistant, Bixby, things like that. And I also used to host a lot of meetups, webinars, workshops for Amazon Alexa across my country and sometimes online. Created courses with O'Reilly, other providers as well. And for all those efforts, Amazon did recognize me as an Alexa champion. But last 2 years back, I decided to pivot my career because I felt like I spent a lot of time building bots. I decided to come into identity, and I joined Okta. Now I help businesses solve their customer identity-related issues at Okta as a solutions engineer. Other than work, I love playing chess, so if anyone is interested, please find me at the booth later on for a game. And I also love watching dystopian movies. I love learning new languages, and I love traveling. I've been to 22 countries so far, and with a lot left to go. And yeah, if you're curious about the last point and something about monkeys, so one of my apps actually helped save a little girl from monkeys which had invaded her house. I know that sounds wild, but if you want to learn more about this story, again, find me at our booth. It's just below this floor, right by the stairs. You won't miss me. All right. Okay. With that in mind, let's talk about something that happened to me very recently, which will set up the tone for this talk. Like I mentioned, I love traveling. So this is my first time in the UK, and I thought before coming to London, I should do a bit of touristy things. So over the last weekend, I went to a small city called as York, about 2 hours from here. Pretty quaint, quite a historic city, and I loved my time there. Now, when I was planning my itinerary, my friends told me, if you are visiting York, and since you are going to be there on a Sunday, you can't miss eating a Sunday roast. I thought, yeah, I love traveling, I love food, I'm definitely going to hit one of the pubs for a Sunday roast. Now, to tell you something, in India, we don't usually do reservations. There are a lot of places, so we just walk into the restaurants and usually find a place. And keeping that in mind, I didn't bother to make a reservation at any place. So when I was in York, I just researched which is the best place to find a roast. And I just went to the first place that showed up on Reddit, like any tourist would do. And as soon as I entered the pub, I asked them, can I get a roast? And they are like, sorry, we are fully booked. We can't help you. I was disappointed, but then what will I do? I just researched the second place, and I went to the second pub. And there, again, I asked the same question. Again, I got the same response. No, we are fully booked. Third pub, same story. Fourth pub, sorry, can't help you, mate. I was pretty disappointed at that point. But you see what is happening here, an interesting thing. In all the 4 pubs that I visited, I was allowed to get inside the pub. No one asked me for my ID because I definitely look more than 25, and I was able to talk to the bartender, maybe even order a pint. But while I was able to authenticate inside the pubs, no one was ready to serve me a roast. Basically, I was not authorized to get a roast. So with that analogy, I would like to set up today's talk that just like the pubs, you can give access to anyone to your application or your website, but you don't want them to access certain areas. That's where authorization comes in. You can have anyone visit your website, but you won't want any random stranger or a tourist on your website to access the admin capabilities or access other user-sensitive information, things that they are not supposed to access. So yeah, that's what happened to me in New York, but thankfully, a nice pub finally took me, served me a Sunday roast, and trust me, it was worth the wait. I enjoyed it, and yeah, but you can't be that liberal when you are building your applications. You cannot depend on the kindness of strangers, and you have to make sure the authorization is always right whenever you build it. Cool. All right, so that was the informal introduction. Now let me just set up the talk formally. So today we are going to talk about why is authorization important, and then we will move on to how have we been doing authorization so far. We will talk about how access control has evolved over the past few years and what are the different methodologies we have implemented to do it. Then I will introduce you to an open source tool called OpenFGA, which is going to be the tool that we are going to implement fine-grained authorization with. OpenFGA was built by my company, Okta, and donated to Cloud Native Computing Foundation, so it's being run by them now. And then I will talk about FGA Playground, which is another free software. You don't need to sign up for that. You can just use it to play around with OpenFGA models. We'll see a short demo of that. And lastly, I will leave you with some tools and resources for you to further build upon your knowledge of fine-grained authorization. All right. Yeah, let's talk about authentication and authorization. I already set the tone, but let's revisit it a bit formally. Okay, so what is authentication and how does it differ from authorization? Authentication is essentially who are you, and authorization is can you do that? So the moment I walked down the front door, they just validated this, they checked my ID today morning. Am I really Ashish? Am I supposed to be a speaker here? And once they validated that I am Ashish, they gave me a speaker tag. Now, with the speaker tag, I can access all these talk rooms, but I can also access the speaker room. So I'm authorized to access another room which a general attendee might not have access to. So that's how authorization will define your access to different resources. And while authentication just confirms you who you are, authorization actually gives you permissions to access different resources in your application, the website, and we can see some examples of how these permissions differ. So permissions are actions that a user or entity can do with a resource. And it could be as simple as entering a hotel room. If I have paid for a room, I get an access card. Now I can access a room, but it has to be just my specific room. I cannot use that card for any other rooms. Permissions can also be given to edit, view, share a file. Like in Google Drive, how if we want to share the access with someone, we give them permissions like you can be an editor, or you can be a viewer, or you can just be a commenter. So we can define what kind of permission people will have. Now, if I pass my bar exam, I have a permission to practice as a lawyer, but if I don't pass the exam, I cannot represent anyone. And simply, you define access controls for your application as well. Whether someone is an admin, they will have access to specific features which are not available to regular users in your application. Now, why is authorization important? The main reason why authorization is important because OWASP did a research in 2021 where they figure out what are the top 10 most common web application security risks. And as you can guess, the number one on that list was broken access control, which essentially means that the authorization on the websites have severe flaws, which means unintended people are getting access to resources that are not meant for them. So it's a time-sensitive problem. So we cannot let anyone access all the areas of our website. So we have to figure out how to fix this access control issue, and that's why authorization is important. Now, there are other places where authorization can affect your business. And the first one I already talked about is access control, where you give and define which users have permission to which resources, what level of permissions they have, how many days they have permission for, what other contextual things like where exactly do they have permission for. Like someone can have access to a website only when they are in the company's intranet, but not when they are working from home. So you can define the granularity of what access someone has. Also, authorization is important when it comes to access provisioning. Let's say you work in an organization which has 500 different employees, and all of them need to have access to a bunch of different applications, 200 different applications that they might need to do their day-to-day jobs: Gmail, Slack, Asana, Zoom, Salesforce, and number of jobs. And even within Salesforce, let's say if I'm on the sales team, I will have different level of access versus if I'm on the marketing team, I might have a different level of access. So to configure all these different types of access and provision them when a new employee signs up with the company, you need to have some sort of formal authorization mechanism so that you are not giving away unintentional access to someone. Like if I'm a developer and I don't have anything to do with the Salesforce accounts data, then I should not have access to it. Maybe I won't do anything malicious to it, but who knows, by mistake I can do anything. By I'm just poking around and maybe changing some, marking a deal as closed win, even though it's still in the stages, things can happen. So rather than leaving things to chance, you just don't want people to have access. The principle of least access should be there. Also, another important thing is when you offboard an employee from your roster, how do you ensure that he no longer has access to every application that you provisioned him for? That's, again, another thing you need to take care of, because if you ended up on good terms, all good, but let's say you didn't end up on good terms and he still has access to valuable resources, then things might go haywire. I was a freelancer. There were times when I didn't get paid for my work and I still had access. And you can imagine what I did. So things can happen. So you have to be careful around that. All right, security. When it comes to security, it's again the same thing, that you make sure that people who have access to the sensitive data only have access to the data that they are intended for. They are not looking into other customers' data or other users' data. And essentially, you just decrease the surface area from where breaches can happen or misuse can happen, or let's say insider threats are taken care of. It's just all about, authorization is all about making sure there are less chances to mess up things internally or by mistake. And in doing that, you improve your overall security posture. The next one is privacy and compliance. If you are going through to meet some sort of compliance, PCI, DSS, HIPAA, SOC 2, things like that, then you need to be very careful about how you handle the user's private data, how you store them, who has access to them. All these things will need to be in order if you are going to meet the compliance. There will be audits, there will be reports in which you need to tell which people have access to what. And this also helps like you with tracking when there is unintentional violation of any policies or who did something which was not supposed to happen. If you have a centralized authorization mechanism, then you can figure out where things actually started going wrong. And then you can walk back to the source of the issue and rectify that. So privacy and compliance are, again, dependent on authorization. And lastly, scalability. Scalability essentially means that you are helping your developers save time and making sure that they spend their time and efforts on building the features which are core to your product, like your main business use cases, rather than spending time on figuring out access control or resolving issues around who has authorization to do what. Plus, if you look at the traditional ways of doing authorization, people just do everything inside the application code on the application layer itself, where gets very difficult to maintain or improve the situation, improve the current standards. So your developers are busy fixing authorization issues rather than solving or launching new features, working on them. So scalability efficiency decreases if the authorization is not handled properly. Now, since authorization is that important, it affects different aspects of your business, and if it's not done properly, it makes you lose revenue, then why don't people do authorization? Why don't they focus on that to get started? The main reason is that authorization is very complex to implement. And what makes it complex? Because you have to think from the big picture. Like, there are a number of users. Let's take the same example. There is a company, 500 employees, so 500 different users. Now, these 500 users will have multiple roles. Some can be admin roles, some can be regular members, some can be super users, some can be analysts, some can be finance, different kinds of roles. Now, each roles will also depend on what type of team they are belonging on. So groups of users will be there. There can be product team, there can be engineering, there can be IT admin, there can be a variety of different teams or groups of users. Next, there will be a bunch of resources they have access to. Now, some people will have access to Team Asana, some people will have access to the team's GitHub, some people will have access to the team Salesforce, HubSpot. And even within them, not all developers will have access to all the repositories in the GitHub organization of the team. They will have access to different repositories. Some salespeople will have access to different deals in Salesforce. They won't have the same level of access for even the same resources. And then the permissions might also differ. Some developers will be an org admin for a repo, but some developers will only be just contributors. So the permissions can differ again. So 500 people, different groups, different permission, different resources. It all adds up to on an exponential rate. Plus, let's say a developer decides to leave the team. Then you need to be dynamic enough that you take away access rather than using long-lived access from my previous example. So the rate of change will also affect how you design that authorization part. It has to be dynamic, it has to scale well. So let's look at how people have tried to solve the authorization problem over the last few years. We will talk about the different access control methods. Well, the first one was back in the 80s. I think they tried to do just read, write, execute access control, where you were just talking about, do I have read access to a certain resource? Do I have write access to a certain resource? And that's how they started building access control methods. But later they moved on to other ways, like role-based access control, attribute-based access control. We'll start talking about these. So to talk about this, I would like to share an example with you, and we will use this example as we go through the different authorization mechanisms, and we will build upon this example. So this is a sample API pseudocode that returns documents, and in the code there is just a couple of lines. In the line number 3, we are just using a database to find a document based on an ID that we receive from the API, so it's a GET request. And then we return back the document. Now, this is just an API call for the document. Let's see how we add authorization layer to it, where only people who have access to it can actually retrieve and use the document. The first way to do it is with RBAC. RBAC stands for role-based access control. This is the most common way people implement authorization in their websites, their application. And when we use RBAC for authorization, we are essentially checking for roles. Whether the user has a certain role, then they can access the document. If they don't have access to that role, then they won't be allowed to access it. They will get a 403 forbidden error like that. So in line number 4, we are again finding the roles of the user, and then we are checking if the roles include employee or manager. Then if the roles don't include employer or manager, then throw an error. If the roles include that, then proceed forward. And line number 9 is the same as before, where you are retrieving the document and returning it back. Now, what are the downsides to implementing authorization with a role-based access control? The biggest downside is that it doesn't scale well when there are many roles. Just imagine there are like 50 different roles in my organization, and then I will have to write if roles not includes employee, manager, accountant, developer, engineer, product manager. It will be a long list of if-else statements. So that's where role-based access control doesn't scale well. Let's say I need to modify a role later on. I need to add a new role. Then I need to look at all the places where I have a check like this and then add a role there. It might lead to inconsistencies that I might miss adding it somewhere, and then I will spend my time debugging it. So it doesn't scale well when you have multiple roles. But if you are just running with like a couple of roles and solving a basic use case, you can just run ahead with RBAC. So whatever I'm talking about today, there is not a right way or wrong way to do things. There are different ways to do different things. So just keep that in mind. Another way to do RBAC is with permissions, where you are using RBAC, but you are using permissions that you get from the JWT token instead of predefined roles. And here you are not checking, you don't have a big if statement where you are checking against all the roles that you have, but rather you just validate the permission that you are getting from the token and then see if the permissions include that specific one, then you give them access. Like in line number 4, you are checking, retrieving the permissions and then checking if the permissions include documents view. If the permissions don't include documents view, throw an error. If it includes, give them access to the document. Downsides to this, how do you grant access to a single document? Because still the permission we are including is a blanket permission. It will give access to 50 different documents if there are 50 documents in the folder. And if you wanted to give like access to only one document, then you might have to create like 50 different permissions, which again goes back to the previous point, doesn't scale well. But if you need to change access to just one document, you have to make that change at every place in your code base. And another problem with using JWT-based permission is that how do you revoke the permission? Because JWT will be active until it expires. So it could be 5 minutes, it could be 1 hour, depending on how much time you set up. And even though you don't want the user to access the resource after the time has expired, because the JWT is still active, they can still continue to access those resources. So that's another downside. And lastly, token bloating. If you add a lot of different permissions to your access token, it will increase the size of the token. And if the token size is too much, it might cause issues with some proxies when they try to retrieve the token. So again, if there are multiple roles or multiple permissions, not a good idea to build with it. So what's a better way to do authorization? Let me introduce you to ABAC. ABAC stands for Attribute-Based Access Control. This is where we are trying to move from coarse-grained authorization methods to fine-grained authorization methods, where we are having more intricate ways, more granularity of how we give permissions, check for permissions. Attribute-based access control depends on attributes. It checks access based on the different attributes a resource can have or the user can have. Some examples of it could be, does the user belong in the product department? Does the user belong in the marketing department? Or are they accessing this resource from inside the office intranet? What is the time of the day are they accessing this resource? Are they accessing it during their office hours? Or are they accessing it outside of it? It could also be based on the resource, like there is a document. Is the document inside the product roadmap folder? Or is it not within the folder? So attribute can be time, place, IP address, anything that can associate with that resource. All right, from this example, this is an example of where you have a document which is inside a parent folder, and that folder is within another folder. Attribute-based access control works by checking access on all the different levels. It will check whether the user has access to the top level folder, then it will check whether the user has access to the folder within it, then it will check whether the user has access to the document there. The problem that starts with ABAC is, for such a use case, you need to recursively check access at multiple different levels. And then you need to calculate whether the user has access to the first step, the second step, the third step. And then once you have finally done that, then finally you can check it against the document. Am I supposed to be accessing this document? And then if you find that the answer is no, then all the effort goes down the drain. And while you are checking all these attributes, you are also interacting with the product database itself. So that may lead to latency on when you are hitting your databases, because attribute-based access control is again done at the application level. So with that in mind, let's see what is the solution to all these problems. Because the traditional methods of authorization aren't quite cutting it, majorly because of 3 main problems. The first one being the complexity of implementing it when there are more than one roles, or there are multiple permissions. When you want to give access to a specific resource, then that's a problem. It is inefficient because it leads to massive development effort when you want to make a change. It leads to inconsistencies when you take away provisioning, take away the access from a specific resource, and you are not too sure whether you have taken away access from all the different places where you are having authorization checks. And it creates like a security and compliance related risk as well, because by mistake you might miss something, and that means you are not meeting your compliance. You are leaking away some data which is not supposed to be seen by everyone. It could potentially cause breaches, and that will definitely not end up well. So with that in mind, let me introduce you to relationship-based access control, also called ReBAC. And ReBAC solves a few of these problems I talked about while explaining ABAC, RBAC. The first one being that when you are building using ReBAC, you don't need to specify all the variety of different roles and responsibilities. You just need to have some sort of one-to-one relation between one object and another object. So users and object can have one relation, and the rest of the relation can be inherited, and the system can figure it out. So from our previous example, we just want user Kate to have access to a document roadmap. Now, there are a few ways of doing it. You can directly assign user Kate to the document roadmap, but in this example, we are just giving user Kate access to the folder product. Now, the folder product contains the document roadmap. Nowhere we have assigned user Kate direct access to roadmap, but since folder product has document roadmap and user Kate has access to folder product, she has inherited the viewer relation, and now she can read the document roadmap directly without us specifying whether she has access to it or not. The way this improves things is now I don't have to give her access to specific documents. We just have to specify one folder name. We can take away access easily. And we can go even fine-grained. If we don't want a user to have access to the complete folder and the direct document, we can just define another relation. User Pete can read document roadmap, and we will be sorted. Now, it might seem very similar to how Google Drive functions or Google Docs function. Essentially, they work on the same idea. So the whole OpenFGA tool that I'm going to talk about is based on Google Zanzibar. It's a paper Google released which talks about relationship-based access control, and that's the technology they use in building their own software, Google Drive and Google Docs. All right, to sum up the access control discussion, I have this slide. So it all started with being as basic as, does Kate have read access to this file, which was the most primitive way of implementing access control. Then we moved to role-based access control, where we are checking based on roles. Is Kate in the product manager role? If she is, then she can access the document. These are examples of coarse-grained authorization, where we are just leveraging like one attribute. Does the role match? All good, you have access. If the role doesn't match, you don't have access. Then we look into attribute-based access control, where things start getting a little bit fine-grained. We're checking based on attributes, like what's Kate's department? If it's product, all good. Is it working hours for Kate? Yes, it is working hours. So we check two attributes, and we can even combine the attributes. If both of them are yes, then Kate has access. Otherwise, she doesn't have access. Lastly, we come across relationship-based access control. It's similar to ABAC, but it's an extension of that. So we are checking, is Kate is in the product department? We check the attribute. Then we check the document. Is the document in the product folder? All good. Now we are checking, does the product department have viewer access permission to this document? Which it does. But nowhere we checked whether Kate has access to the document. We don't have a direct relationship, but it was inherited from the diagram I showed earlier that Kate has access to the document. And that gives power to fine-grained authorization, where we combine multiple attributes to reach an authorization decision. Okay, now let's talk about how we implement fine-grained authorization in your applications. So we will be talking about open source software called as OpenFGA. Now this open source solution is owned by Cloud Native Computing Foundation and maintained by my company Okta, and there are a lot of open source contributors from other organizations as well who contribute to this project. And it is also used as the core of Okta FGA, which is like a managed offering that we provide. Okta FGA has a DynamoDB backend, whereas OpenFGA can be run on your server by yourself using Postgres, MySQL, SQLite, and it was inspired by Google's Zanzibar paper, which describes how all authorization for Google's resources was built. And the best thing about OpenFGA is it allows you to grant access to individual resources in your system at different levels. So you can have different permissions for different users. You can control the level of access for every user. And it's not hard-coded, so it's not in your application level. So as you grow, you can iterate, making access control more granular. So if you find something that you need to change, it's much easier to change when your authorization layer is not built inside your application layer. So as your product grows, you can make access control more granular. So where does the authorization layer lie if it's not inside the application layer? So this is an architecture of how a normal application's authentication layer will look like. So user will log in to their application using any identity provider. It could be any open source provider, open source library, or any vendors like Auth0, Clerk, WorkOS. There are a bunch of them. You can use anyone here. Once the user authenticates successfully, then they get an access token. And that access token can be used to call APIs, services in the application layer. And here you have like some validation or authorization, RBAC-based, ABAC-based authorization can be happening on the application layer. But once you implement FGA, then the first part remains the same. The user is logging into the application using an identity provider. They get an access token. They have access to the application. But once they hit the API, before they hit the API, they can call an authorization check to an external API before they hit the main resource that they want to access. It will be the authorization check that will happen with a tool like OpenFGA, where you are checking user with user ID, does they have access to a specific resource? Does Kate have access, read access to a document call roadmap? You can check things like that just before you get access to your main API. So once you run that check, you will get an answer. Does Kate have access? Yes. If she has access, then you can proceed further and call your API. If she doesn't have access, you can just return no at that point and throw a forbidden error at that same stage. This way, your authorization is separate from your architecture, and you can maintain it separately. It will be a separate database where you are writing all the relationships and all the tuples. And let's talk about that next. How do you implement OpenFGA? So as I mentioned, it's centralized way of authentication, authorization, where you keep the authorization layer separate from your application code. And if you have multiple applications, you have a website, you have a mobile app, you don't need to write code in both of them separately. You can maintain it separately at one place, and then both your website and your mobile app can talk to the same authorization API. And that's how you will standardize it across all the products in your company. And it also helps with auditing and logging because, again, you are just looking at a central place for all the logs. You can see where the authorization policies were violated and amend them as needed and implement new features accordingly. Okay, so the steps to use OpenFGA. The first step that you need to do while implementing FGA is defining the authorization model. In this step, we talk about how we add different elements to our model. Then we add some authorization data, which is adding different types of relationships. Then we write assertions to check whether our model works. And finally, we connect to our application. Let's look at the steps one by one. Okay, let's look at authorization model, relationship tuples, and checks. These are the three key elements when you implement fine-grained authorization. So the first one, authorization model. It looks something like this. So the model has a schema. You start with defining which are the core components of your model. Like from our example that we are running with, we have a user, we have a document, and we have a folder. These three elements are the key components of our model. And then we define like relationship tuples. What are the relationships between these different elements? And lastly, we define the access control checks, where we are just validating, does our model work? Does it work according to the relationship? So for the first one, authorization model, we start with defining the elements. We define user, then we define document. And inside document, we have to define relations. What kind of relations can this document object have with other elements like folder or user? The first one is parent relationship. So we define that a folder can be a parent of a document. The next one is owner relationship. Who owns a document? A user. Then we define who can be a viewer of the document. It could be a user, like the user who owns it can obviously view the document as well. Or it could be an owner. So the owner can view the document, or user can be someone who is directly assigned as a viewer. Or the third one is interesting. It could be a viewer from parent. So if there is a parent is a folder. If there is a user with, if there is a folder and it has a viewer relationship, it can, inside of it, it can also be a viewer for a document. So for the third type folder, we define a viewer. So if user Kate is a viewer of a folder product, then, and if the folder product has a document roadmap, then user Kate is also a viewer for the document roadmap, because we have defined the third relation that a viewer from parent can also be a viewer for the document. All right. And how do we define all these data? We define that is in the relationship tuples. So authorization model is where we define the basic schema of how things are going to run in our database. And relationship tuples is where we actually provide the data to instantiate our authorization models data with. So the first one, user Kate has a relation of viewer with the object folder product. So we are just specifying that Kate is a viewer of product folder, because that's in our authorization model, so we can define this relationship tuple like this. The next one that we are defining is that folder product is a parent of the document roadmap. The next relationship is user John is a viewer of document roadmap. Now user John doesn't have any access to the folder product. He's directly assigned to the roadmap document. Whereas Kate doesn't have direct access to roadmap. She's assigned to the folder instead. Now, once we have defined our relationships, the next thing we need to do is check whether these relationships work. And we can do that by writing some assertions. And our first assertion is user David a viewer of document roadmap? So FGA will go to the authorization model. It will check the relationship viewer. It will see that a viewer can be a directly assigned user, but we don't have David as directly assigned anywhere to the document roadmap. We only have John and we have Kate who have access to roadmap document. So the assertion will be false because David doesn't have any access to it. For the next check, we are checking, is John a viewer of roadmap document? Now this assertion will be true because we have directly specified it in our relationship tuple that John has access to the document. The third one is, does user Kate have access as a viewer to the roadmap document? Now this one will make use of two different tuples to figure out that yes, Kate has access to document roadmap because she has access to folder product, and folder product is the parent of document roadmap. And so Kate indirectly has access to it. So now when we implement ReBAC, we think from a different perspective. We no longer directly check like, can a user U perform an action A and object O? Like, can Kate view the document? We don't directly think in terms of actions. We think like, does Kate have viewer relation with document roadmap? That relation can be inherited either directly or through a series of nested steps from a big hierarchical graph rather than having direct access. So when we build our model, we have to start thinking about in the second way. Think about the relations between one object and the other object. Cool. I think that was a lot of talking. Now I will like to show you a bit of FGA demo. And for my demo, I'm going to be using the OpenFGA Playground. It is another tool built by Okta, but it's free to sign up. You don't have to provide your details or anything. You can just go to the website and start playing around with it. It has some pre-built models, and you can also create your own authorization model to play around with it on that. And it's mainly for learning purposes. We don't recommend to use it in production because the data is only stored locally in the browser. So yeah, let's take a look at that. I will just, okay. Is the screen visible at the back, at the corner? Can you guys see the schema? Okay, if not, Okay, this is basically the same model that I explained in the previous slides. It looks similar to this. Yeah, it's the same thing where you have like 3 different elements: user, document, folder, and the document object has different relations like parent, owner, viewer. So you can specify the schema here, and then you can write the tuples like I showed in the example, and then you can also write assertions in this tool to check. Now, once you have run all these things, either you can just run the assertions here, which will show you how things work, or you can go to this query part where you can write queries in plain English, and it will show a whole graph of how decision was achieved. So let's try something. Is user Kate related to document roadmap as owner? I don't think she's an owner. Let's just try out the viewer part first. So, one second. So the answer is yes, and what OpenFGA does, it goes through a whole tree of how it how it made the authorization decision for that specific user. It looks through the different possibilities, like who are the viewers for document roadmap. It started with the direct user. There is one direct user, user John, who is the roadmap document viewer. Then there is related from the same object, people who are owner of the document will have viewer access. And then it figures out through a tree that user Kate also has access because she is a direct user of folder product, and folder product is a viewer of the document roadmap. So that's how the authorization decision was achieved. And if we just look at user John, now for this, the tree is as simple as that. He's directly assigned, it worked out. But if we check out for another user, it doesn't work because user Pete is not related to the document as viewer, so there is no access for user Pete, and none of the paths matched how Pete will have access. So you can use FGA Playground to play around with different authorization models, and there are a bunch of different pre-built examples, like there is an expense-related example where the use case is essentially how you can submit expenses. Let me see if I have it here. Yeah, this is the authorization model where there is an employee and a report. An employee can submit an expense report, and their manager can approve the report, or their manager's manager can approve the report. So define can manage relation specifies that an employee can be managed by either their manager or the next one up in the hierarchical order. And then there is the second type, which is type report, where there is an approver. Approver is usually their manager. From the submitter, can manage from submitter, and submitter is essentially the employee who submits the report. So let's take an example that there are 4 people. Emily manages Sam, Sam manages Matt, and Matt manages Daniel. And I have written a few, there are a few tuples here already. Employee Matt is a manager of Daniel, Sam is a manager of Matt, Emily manages Sam, and Daniel submits a report, which is called Daniel Chair 1. Sam also submits a report, Sam Chair 1. And now let's see who has access to approve, let's say, Sam's report. So I have, again, some assertions here. Can employee Matt manage employee Daniel? So if we just check our tree, yeah, employee Matt can manage Daniel because Matt is a manager. And then we see, can Emily approve Daniel's report? Because Emily at the top of the hierarchy, she can approve it, even though they don't have a direct relationship to it. So let's just try that one out. This is just a playground, so it's a bit finicky. All right, so this is the decision tree which was built to figure out can Emily manage it, and yeah. Oh, all right. So essentially, I'm not good with the touchpad. So yeah, this is the decision tree that was made, which figured out can Emily manage um, and Sam to manage Daniel to approve their reports. So you can play around with the playground here. There are a bunch of different models. There are even more complex models like how Google Drive functions. So there are documents, you can define multiple relations, like who can be, I showed a very simple version of it in my demo, but there can be a folder, there can be document, there can be create file, groups, user, different things. And there is another example which is quite cool, which is GitHub. GitHub model can have organizations where there is repo admin, repo reader, there can be repos. Repos will have admins, maintainers, owners, triager, writer, different roles and relations. So do check out this playground, and you don't even need to sign up, it's free to use. You can just build your own model with it. If you want to build your own model, you just have to go towards the side. 1 second. Yeah, you can build a new store and you can start with building your own authorization model, write your own relationship tuples to it, write your assertion checks. And there is an API available as well. So if you want to query this model, you just need to get the model IDs and you can just hit them with from the OpenFGA APIs. All right, back to the slideshow. Okay, so now I would like to just share some tools and resources that you can leverage further to build upon your fine-grained authorization knowledge. The first thing that I would like to briefly talk about is we at Okta also offer a managed version of fine-grained authorization. And if it's suitable for your business, you can always take a look at that. The OpenFGA product is free to use, and our managed version is built on top of it. And the main things that it offers is high availability, SLAs, for meeting compliance. There is low latency, and you can deploy in like public cloud, private cloud. It leverages DynamoDB and replication, all the good stuff AWS provides. But if you want to deploy your own OpenFGA server, you can connect it to your Postgres system, MySQL, SQLite. And this managed version ensures that you are compliant, and it's available in a variety of different regions that AWS has. All good. Okay, other than that, we do have some high quality tooling and developer experience resources. Like there is a VS Code extension that you can use while writing your models, which will tell you if you are making any mistakes. There are SDKs for OpenFGA in all the common languages, JavaScript, Python, .NET. You can use the GitHub action to deploy your models and for testing it. There is a CLI available as well to run the model checks, write queries, add assertions, all these different things can be done through the CLI if you want to live in the terminal. And for every feature that I talked about, like updating the model, writing relationship tuples, updating assertions, executing the checks where you are validating, we have APIs exposed for all the different features. So whatever can be done through Playground or our managed version, you can just go to the APIs and this is the API documentation link, and you can just leverage APIs for that, or the SDKs, whatever you prefer. The API implementation looks somewhat similar to this, where this is a post request example of the check API request, where you just call the FGA client.check method and you pass in the user ID, relation, and object. So everything in FGA comes down to the user type, the relation, and the object. And you are just validating, is user 8168, does the user 8168 have a can view relation to the document roadmap? If it does have the relation, the result is true, and then you can go ahead with the rest of your business logic. If the result is false, you can just throw the forbidden error there and then. And just again, just an example of how you implement it in the code. If it gives a result of allowed is true, then go ahead with sending the document, return the document. If allowed is false, then just throw an error and end the logic right there. Another API example is this write example, where you can leverage the OpenFGA API to write the relationship tuples. And you just specify the user, relation, and object, and all these relationship tuples will be uploaded. You can also delete the tuples using the APIs, and Just make sure that whichever model you are using, once you are hitting the APIs, you specify the correct model ID, because every time you update your authorization model, a new version is generated. Tuples, relationship tuples can exist. Okay. Okay, another just an API implementation example. There is a create document function. You first check whether the user is authorized to create a document using the check API. If the user is not authorized, throw the error. If the user is authorized, then you can allow the user to write some new tuples in the database. So it can be a user relation owner mechanism again. All right. That pretty much brings me to the end of our conversation today. And I would like to end this with talking about how you should decide, is FGA the right product for you? Now, this thing will pretty much depend on 5 main features. The first one being granularity. If you want your customers to have, if you want your users to have granular permissions to access different resources within your application, your system, different resources, different authorization checks, which are also dynamic and based on a bunch of different attributes. If granularity is your requirement, FGA is the absolute best tool for you. If you want to improve the developer efficiency by making sure that authorization is separate from your application layer, so your developers have to spend less time figuring out access control issues, again, FGA will fit the bill there. If you want to have efficient compliance and auditing related capabilities, you want to meet different compliance, you want to check the audit logs frequently for any violations or raise alarms when things go haywire, then again, FGA can be a good fit for you. And yeah, you improve your overall security posture, because when authorization is implemented inside the code, it has a tendency to lead to inconsistent implementation throughout the application layer. But when authorization is implemented centrally, then you just have one place to check where things might go wrong. So the surface area for malicious actors to attack your application reduces when you implement it centrally. And lastly, complexity. Customers usually don't have a single pane glass of view when they are looking at access control when it is implemented through traditional ways. But with the centralized authorization mechanism, you just have one place where everything is implemented. The complexity surely comes down to that. And with that, if these things work out well, then you can efficiently scale your business as well. So you don't, as you get more users, more resources, you can just modify that central layer with new relationship tuples. You can change the authorization model. You can take away permissions. Like there is an owner relation which used to have viewer relation as well, but you can take away viewer relation and you don't need to change the whole database. You just need to modify your model rather than all the relationship tuples. The relation name can still be the same, but the permissions are reduced. So with these things in mind, if they work out, FGA is the tool for you. How can you explore OpenFGA further? These are some links that you can take a picture of. We have a open source repo. The Twitter is also quite active. We have a YouTube channel as well, which you can go. And if any of you are on the CNCF Slack, we have a dedicated OpenFGA Slack there where people from the community and also people from Okta hang out, answer questions. I think we do office hours every Monday, or if I'm not wrong. And there is a Auth0 community as well, which is free to use. You can come there, ask questions around FGA documentation, and yeah, the playground what I showed you. Plus, thank you so much for being with me at 9 a.m. I know it was an early start for everyone. And if you have further questions or if you want to brainstorm some FGA models, you can come by our booth. It's just below this floor and right by the stairs. And we will be happy to help you out. We have a couple of FGA experts sitting there waiting to answer your questions as well. Thank you.